Hi friends, so far we have talked about the various components fitted in the internal combustion engines and also the critical systems of the internal combustion engine, that is the cooling system, then the lubrication system, then the fuel system, that is both electronics and as well as the conventional fuel system, and air intake system. As part of the air intake system, we also talked about the turbocharger, how the turbocharger works, and what is the use of the turbocharger in the engine, how the turbocharger has to be maintained. Now, some of our friends or viewers asked about to explain about the tappet setting in an internal combustion engine. Somebody call it as tappet setting and someone call it as a valve lash setting. So, what is the necessity of a tappet setting in an engine and how the tappet setting has to be done? I am going to explain in this video. Friends, before talking about the tappet setting or the valve setting, let's have a brief look about the effect of the heat on the metals. How metals behave when its temperature changes. Look at this figure. This, the blue one, is the metal at different temperatures. These circles are to be considered as the molecules of that particular metal. Here in this block, the temperature of the metal is 5 degrees Celsius and it is heated to 20 degrees Celsius. So increase in temperature by 15 degrees. You can see this. These molecules are moved apart from each other. That means the occupying more area. Okay. Then the metal is further heated to 40 degrees. That is a temperature increase by 35 degrees. Then the molecules inside the metal has moved further apart each other, occupying further more volume. Let us consider this horizontal one is a metal bar, which is 2700 millimeters at minus 20 degrees, and the same is heated to plus 30 degrees, that is a temperature increase by 50 degrees, and the change in the length is plus 3 mm. The 2700 millimeters bar has expanded to 2703 for this particular material or metal. You can see this. This is called a kind of expansion joint, flexible metallic expansion joint. Both ends, two metal tubes are connected. This metal tube, when its temperature is changed, it is expanding. When the temperature is increasing, it is expanding. When the temperature is decreasing, it is again contracting. So the expansion contraction is being taken care by the flexible metal bellows, which are called the expansion joint. This action is called the thermal expansion of a material. Thermal expansion means it is a tendency of the matter. Matter may be a metal, a liquid, whatever it may be. Thermal expansion means the tendency of a matter to change its shape, its area, or its volume and density in response to change in temperature. The temperature increase, it may expand. The temperature decrease, it will contract. The next point is that when all the metals do not expand equally with the change in temperature. So the expansion will be, the rate of expansion will be different from metal to metal, which is called as the coefficient of expansion. The amount of expansion depends on the nature of the metal, which is called the coefficient of expansion. This is a kind of expansion joint, and here we can see, we all have seen these rails on which our train moves. The rails do have the gap and which are connected with the fish plates. Okay, so this joint is called the expansion joint. Why this gap is provided? Let us see. See this, when the temperature is increasing, the rails are expanding and the gap is reduced. You can see this. Again, temperature is decreasing, the rails are contracting and the gap is increasing. Rail is a steel material. This is how the steel behaves with a change in temperature. So this gap is provided to take care of the expansion when the rails attains certain temperatures because of the running of the wheels and because of the friction generated due to the running of the wheels on these rails, because of the change in the atmospheric temperature, etc., etc. And if we do not provide this gap, what is going to happen? And there is no space for the expansion. So to accommodate the increased length, so these rails try to get deformed like this. This is a kind of deformation. So when this deformation takes place, the uniform distance between these two rails, which is most important to run the train, is affected, is disturbed, so that there is a possibility of collapsing the train. This is how metal behaves with the change in the temperature. Let us look at some more expansion joints. This is an expansion joint on the flyover. Okay, this one. In between they embedded some kind of cushioning material. This is also a kind of expansion joint here and here and here. This is another expansion joint between the concrete blocks. It may be a road, it may be a roof slab, whatever may be. This is also another expansion joint. The whole purpose of all these expansion joints is to take care of the change in the dimensions of the particular material or matter, which occurs due to change in the temperature. Now let us go to the main subject. This is the valve train of a 4-stroke engine. This has already been discussed. Camshaft, lift in the cam follower or tappet, which lifts this push rod. Again, push rods with the rocker arm. Because of this fulcrum mechanism, one side it is lifted, the other side it is pushed down the valve, and valve opens. Either inlet air or the exhaust air passes through this open passage. This is how it looks. The main this thing is important is that one. See this figure also. Okay, what I explained. The main critical part is that one. What we are discussing is the valve lash or tappet clearance. The gap between the rocker arm and the valve stem tip. This is the valve stem tip and this is the rocker arm. Okay. The gap between these two is called the valve lash or the tappet clearance. Certain amount of the gap has to be maintained here for the reason what we explained in the earlier slide. This is the valve. Okay. In any internal combustion engine, valves, this is the cylinder head, valves, cylinder head, bottom surface, piston. These are the parts are directly exposed to the combustion chamber where 1500 degrees centigrade of heat is generated during the combustion process. So these parts, cylinder head surface, valve seats, that is valve, and the piston. So these are the parts which are exposed to the maximum heat inside the engine. And another one, when the engine is running, all the parts moving inside the engine gets heated and its temperature increased. Temperature increases. We have provided a cooling system and also the lubrication system to carry away the heat and regulate the engine temperature. Majority of the heat is carried through the cooling system, and some amount of heat also is carried through the lubrication system. That's what we discussed. But still this particular valve, because of its design, that is a lengthy stem with a thin diameter, it expands when it is facing the temperature in the combustion chamber. So when it gets heated, the length of the stem of the valve is increased. The length of the stem of this valve is increased. So where this length will travel not to the bottom side. You can see this mechanism here. This is the valve. This valve is locked against the head surface here. So it is having only free expansion towards the top, not to the bottom, right? So when it expands, if there is no gap here, it goes and touches the rocker lever and creating so many issues which I will be explaining in few minutes. So to take care of the expansion, we have to maintain certain amount of the clearance. That clearance is called the valve lash or tappet clearance. And the valve lash or tappet clearance normally will be more in the exhaust valves than the inlet valves. Why it is more in the exhaust valves? Because this exhaust valve stem and exhaust valve face is always in touch with the exhaust gases, that is high temperature gases. The high temperature exhaust gases always will be passing through the exhaust valve. So the amount of expansion in the exhaust valve will be more compared to the amount of expansion in the inlet valve. So to take care of that excess amount of expansion, so gap will be more here than the inlet valve. This is a kind of valve arrangement, and this is another kind of valve arrangement. The gap what I explained here, that is valve lash, you can see here. This is the gap we have written here. This gaps needs to be maintained, and how much amount of gap is to be maintained will be determined by the engine manufacturer, considering so many factors. That is the thickness or the diameter of the stem, length of the stem, and number of valves on each cylinder, power of the engine, etc., etc. So this gap is to be maintained. This rocker arm is pressing only one valve, either inlet or exhaust. So this particular arrangement is for the engine which has two valves per cylinder, that is one exhaust and one inlet. What about an engine which has four valves per cylinder, that is two inlet valves and two exhaust valves? This arrangement you can see. This is the a set of valves. Let us have an inlet valve, and by the side of this you can see here a set of other valve, maybe exhaust valve. So to operate these two, to open or close both of these valves simultaneously, there is another device is provided which is known as the crosshead. This is the crosshead which is sitting both on the both valve steps. Here it will sit, and over and above the rocker arm will be sitting, which is pressing this horhead, which is pressing this crosshead. In turn, crosshead presses both the valves simultaneously. So here the valve lash has to be maintained. Now in this slide we will see what is the process involved in the tappet setting. This is the 6-cylinder inline engine. 1, 2, 3, 4, 5, 6. This dotted, the dark one are the exhaust valves, and the circle, light circle one is the inlet valve. This engine has 4 valves per cylinder. Okay. So the engine is rotating like this. You can see the firing order of the engine. 1, 5, 3, 6, 2, 4. Firing order means the sequence of the firing of each cylinder in the engine. If number 1 engine, power stroke Firing is nothing but power stroke. If number 1 engine power strokes takes place, the next will not be number 2. The next firing takes place in number 5, then number 3, then number 6, then number 2, then number 4. Why this numbering has given? This is mainly to maintain the balancing, to minimize the vibrations generated during the power stroke and to maintain balance in the crankshaft. So this firing order is essential. So for doing the tappet setting, there are mainly 3 things we have to consider. We should know the firing order of the engine, point number 1. Point number 2, the top dead center of the piston number 1. Okay, the piston in top dead center, the piston will be in 2 times. One is at the end of the compression stroke and at the end of the exhaust stroke. That we should know, which we can know through the timing mark provided on the timing gear. There is a special timing tool is there for so many engines now. The other factor what is to be considered is actually we must do the tappet setting only when the both valves are free. Means the valves are in fully closed condition. Then only we have to do the tappet setting. The another one important, the tappet setting job has to be performed after switching off the engine and taking the ignition key from the switchboard, if required by disconnecting the battery switch. How the tappet setting is to be done varies from model to model. Different model engines have the different process, different procedure of doing the tappet setting. I have given a 6-cylinder CRDI engine how the tappet setting is to be done. I have given in these notes in the last page. You can go through, and if you have any doubts also you can call me. This is how the tappet setting, this gentleman is, you have to first of all choose which cylinder you have to do the tappet setting. Then first of all you have to check up this thing, then put a feeler gauge here, the way you put the feeler gauge of the recommended thickness, then loose this adjusting screw, okay, then adjust this feeler gauge, then again tighten this adjusting screw till you feel mild load on the feeler gauge. I am repeating a very mild load. Then keep this screw like this and tighten this lock nut with the specified torque. Again you recheck that one. Like that you have to perform for all the valves. So why we have to do the tappet setting? Over a period of time of engine operation, parts fitted in the valve train, that is the valves, whatever is there, the valves, the push rod, seats, arm bushings, tappet rollers bushing starts wearing out. When these bushing and these parts wear out, the clearance here is increased. To readjust the clearance, you have to do the tappet setting at specified intervals. And you have to do only as per the engine manufacturer recommended procedure. What happens if the gap is less, that is valve lash is less? Early opening of the valve. The gap is less, valve will open little bit early. Point number 2. Incomplete closure of the valve because of the less gap here, and also mixing of the fresh air with the exhaust gases. Second thing, there is a loss of power and there is possibility of excess fuel consumption, and there will be unwanted load on these springs and which may cause further failure of the springs, etc. What happens if the gap is more here, more than the recommended? So delay in opening of the valve, that is also another issue. And the noise, when the gap will be more, there will be huge noise. When the noise is more, then friction will be more, then wear and tear will be fast, then again the gap will be further increasing more, and some other consequential damages in the engine. So a specified gap has to be maintained, and valve setting has to be a specified gap has to be maintained, and the tappet setting has to be performed at recommended intervals with due care by following the engine manufacturer's recommendations strictly. The very important thing what we all should know is tappet setting is a very precision job. So any mistake done either in selecting the timing or doing inappropriate wall setting leads to catastrophic failure of the engine, even to the extent of the engine block burst. Please go through the page number 4 in which I have explained process of doing the valve setting for a 6-cylinder CRDI engine. In case you have any queries or questions, you can contact me through the email.